Hi all, I welcome you to Zealous Tech IT. In this video, I will introduce you to Apache Spark and a little bit of Hadoop. So this is the agenda for this video wherein we learn what is Apache Spark, what is Hadoop Yarn, Apache Spark architecture itself, and Spark with Hadoop, how Spark is fitting into the Hadoop ecosystem, and then we'll analyze that why there is a need of Spark. So what is Spark? So Spark is the open source framework given by Apache Foundation. So it's mostly suitable for the huge data sets where we have high latency. So as it's the master slave architecture, we have multiple nodes, the clusters of depending upon the company requirement, the company decides the number of nodes, and all these nodes are managed through single resource manager called as a master. So, so uh, talking about the Spark, it's like a master slave architecture where one master is talking to the nodes, gathering resources, and as we know, like data is distributed among the different nodes in Hadoop or any big data system. So we are running on the same lines. We are running the Spark where data is distributed, and Spark is running the parallel computations. So not only the data is among the server, but the operations are also in parallel. So so in short, we can say like we don't need to wait for one step to complete and then start next step. All operations are in parallel. So let's dig deeper into the different layers of Spark. So these are different layers, wherein the bottom layer is the cluster management. This is where Hadoop comes into picture. So we have different cluster management provided, which is Spark standalone. Next is Yarn, then Mesos, and Kubernetes is also there. But these are the most famous cluster management. So what is the cluster management? Cluster management uh, is the process or is the daemon which is running on the master node, which is used to allocate the resources from the worker nodes or on the slave nodes. So Spark, and on the top of that, there is this that is Spark core. Spark core is the functionality of the Spark, which is the core functionality, and this Spark core is using this cluster management. So most of the industry setups are of the Spark are with the Yarn. So it is important for us to understand what is Yarn. So uh, so we should understand. I mean, we should understand what is Yarn. Then we'll understand how Spark work on the Yarn. So coming to the Spark core, as I said, it's a core functionality. Then the basic abstraction is the RDD, which we call that resilient distributed dataset. So uh, and on the top of that Spark core, we are building this functionality like Spark streaming. Then we have Spark SQL, graphics, and machine learning. Then comes the data frames API. So for the ETL side, we are the traditional ETL is in the form of tables where we have rows and the columns. So the data from API does the same thing, wherein it gives the view of columns and tables. So that is built on the top of this, and this can be implemented in all these languages: Scala, Java, Python, and on R. So now, as I said, like in the previous slide, we talk about the cluster management where we have the yarn. So next topic that is very important for us to understand is what is Hadoop yarn. So yarn is the yet another resource negotiator. So it is the process which is running on the master node. So this is typical, very basic example of what is yarn, how yarn and how Hadoop system is 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 set up. So this is the resource manager, which is a master node, and these are the data nodes. So there are four data nodes, and this is the one resource manager. Data node means like it is actually holding the data. Let's say you are loading a file or you are reading a file, then this node manager will hold actual file or data of the file. Sorry. So, and this is our client. Uh, so this guy is managing the resource among this uh, data nodes. So let's understand it by one of the examples. So let's say client is submitting a SQL query or anything or any application of for that matter, which is which is which is which is known by the resource manager. Like resource manager accept the map reduce job. So we'll consider the select query which is fired by the client. So in the from the Hive or maybe from the any big data tool. So any job which is fired from the client is considered as an application in Hadoop terminology. So this application is submitted to the resource manager. So resource managers have a capability to accept the request from the client. Resource manager, once they receive the resource manager receive the request, it uh, it contacts one of the node manager and load and launch the application master. Now application master is the first container which is launched in order to execute the job. This application master will analyze the job. Okay, will see what it will see what are the tasks, and it will it will ask it will go back to resource manager asking for the resources. What are the resources? So resources are RAM, CPU, cores, and storage. So it will ask like I need these many resources to in order to execute your job, whatever the query you fired. Application master will ask this to resource manager. Resource manager will approve the request, like okay, these resources are available. And now application once the request is approved, this application master will launch the container on the different node where it is required. It will launch the containers to the node manager, to this node manager, and to the other node manager. Now, how application master knows, like I want to launch the application on this node manager and this node manager and not this node manager. This is again facilitated by the node name node. So name node is a process which knows that where data is residing in our data node. So application master is talking with the name node, and he knows he's and he knows like where data is stored. So application master get the information and launch, like let's say file, let's say we have employee.txt as a file, and this file is distributed among these two node managers. Then application master will launch the container on these two node managers. So once that application is that containers are launched, job processing continues in the form of task. The application master talks with the node manager to get the status. Once job is finished, they notify application master. Application master notifies resource manager, and whatever the success or failure of the status is notified to the client. So application master then goes away because it is for the application per application that you launch. So this is how the overall yarn architecture in the Hadoop works. So this architecture is also called as MR2, wherein we call as map reduce to architecture in the Hadoop. So we are not still into the Spark thing. We are just looking at how yarn works and associated entities. Now next is the move on to this topic where we actual focus will be focusing on the what is Spark, how the Spark architecture is there, what how it is laid out. So uh, it's again the master slave architecture, and there are different modes of the Spark in a way it operates. It's like a standalone mode, then it is Yarn, then it is Mesos and Kubernetes. So these all are the cluster managements. Like it, there are different implementations in how you can manage your cluster. So these are the four modes where Spark operates. So the diagram that is shown on the left side is the Spark standalone implementation, where we don't have uh, the specific terminology of the cluster management. So here, if you see, here's a driver program, and there are cluster managers, worker nodes, and the different worker nodes. So this is a master node, and these are the slave nodes. So now cluster manager here can be any one of them. So as I said, like most of the setups of the Spark are with the Hadoop. So Yarn, this is the place where Yarn is sitting when we are running Spark on the Hadoop. So let's understand the Spark, how Spark works. So whenever you create any Spark program, the driver program is created. So you are whatever you write in the Spark, maybe it's in Java, in Python, in Scala, and R. So it contains the driver program, which is contains the main method, and this main method uh, opens the Spark context. Now Spark context is the entry to the cluster. So without Spark, you cannot allocate resources, or you cannot go to cluster manager asking to launch the jobs to this worker nodes. So once Spark context is created, cluster manager will launch the one of the cluster manager will talk to the worker nodes cluster and allocate the resources for the job. Like resources means the RAM, CPU, and cores. And once CPU cores are allocated, the driver program will send the job in the form of the task. So uh, there's a two-way communication between driver program and the executors. So there are, let's say, n executor, n worker nodes. Then those all will be talking to the Spark, to the driver program. So so now we have submitted the job. Cluster manager has allocated the resources, and driver program is sending a task to these worker nodes in the form of the task. So sorry, the job in the form of the task. So what is a worker node? Worker node is just like a machine. It's a physical machine which is running the executor. So executor is again the set of resources which in a set of resources which is required to execute a particular job. Cache is the set of the subset of data. Let's say if your file is having very layman terms, I'm telling you, like if your file is having 100 lines of code, then let's say 50 line will be here and 50 line will be here. So this cache is holding that partitions of that file. So uh, so this executor executes this job in the form of the task, and it is talking to driver program. So once the role of the cluster manager is only till you allocate resources. So once resource allocation is done, this cluster manager is not required. Then only driver and worker will talk to each other and convey the status of the running job. So let's move little deeper into this. So as I said, like driver program is running the main method. Main method is creating a Spark context. Spark context is the entry to the cluster, our cluster. Then cluster manager is allocating the resources to these worker nodes. Executor is the is the set of resources. So now whatever the job is submitted, it is submitted submitted by driver. It is converted into the form the task to the worker nodes, and uh, once the user code is sent to the task, the physical plan is generated. The driver schedules the execution of task by coordinating with the cluster manager. So it schedules the job to different worker nodes, and it keeps on taking the status of the job. So that's how it is how that's how the Spark architecture works. And now next part is how in this section we were into the Spark architecture. Now how this complete architecture is sitting on Yarn. So we'll see how Spark on Yarn works. So While working with Spark and Yarn, there are two modes where the job executes, or where the typical job execution goes on. Like there is one is a client mode and other is a cluster mode. So let's look at the cluster client mode first. So in the client mode, we are launching a driver program in the client machine. So if you see, this is a client machine. Our driver program is here. Our main method is here. In main method is creating a Spark context. Now it is contacting to the resource manager, right? Resource manager is launching the first. Now, if you see here, as we are on Yarn, as we are going to Hadoop, the terminology has changed. Like here, data node and node manager is coming into the picture again, because this is the terminology of Hadoop. Again, name node is there. So in back, let's go back to the slide. Here we are seeing worker node executors. Same thing is changing here with the names like data node, node manager. So these executors are running under the node manager. That's how it is. So okay, let's start with this. So as I started before, but let me begin once again. We are launching the our driver program at the client machine. Client machine is creating a Spark context. Spark context is the entry point to the resource manager. Resource manager, in order to run the application, resource manager launch the application master, which is a per application process to the any of the node manager. As I said, application master asks for the resources to the resource manager that I need 2 GB RAM, 10 cores, and some storage, and these requirements are asked are approved by the resource manager. Once it is approved, application manager will launch the containers on the different node managers, depending on the information from the name node. Like name node is application master is talking to name node. Name node says like the data is reside the in order to execute your process, data is residing in this data node. So it will launch these executors on the node managers. Then the work of resource manager is over, because he approved the resources. Now it will talk to the executors and get the status, right? So this process is executes. Now in the client mode, specifically talking about the client mode, one if you exit this system, let's say if you are submitting a job, you submit job and you exit the terminal, then this link is broken and this job will fail. So it's like, in order to run the job in the client mode, it's necessary uh, to to the client machine to be run and up and running. So you cannot exit the terminal, because this link is broken and this job will fail. So it is like just like the Linux shell script, wherein you execute the shell script, and if you close the terminal, your process will abort and your shell script will not execute. So this is way this is client mode, where client should be alive all the time. That is the requirement. Now the cluster mode. So cluster mode is this, it is opposite to the client mode. It's like if you're submitting a job from the client machine, you don't need to be alive all the time. Your job is submitted, you can exit, and although you exit, close your laptop and exit the terminal, or maybe exit the terminal, then still your job will run, because your application is now running because if you see in existing slide, the Spark context is in the client machine, but here Spark context is on the cluster itself. So this is a cluster, right? So it's just like a no hub command in the Unix, wherein we just fire the command, and no hub command will execute in the background and the process runs. So let's again go to the life cycle and understand the difference between cluster and client mode. Here, the client submits the job to the Spark. Request goes to resource manager. Resource manager launches the application master in the any of the node. And here, driver program and now while launching application master, driver program is launched inside the one of the data node in the cluster. It is not here. As the driver program is here, Spark context is also launched within the cluster. Again, it asks for the resources. Resource manager approves the resources. Then it will talk to it will launch the containers, that is the executor. So executor and containers are used interchangeably because these executors are running actually inside the yarn container. So sorry. So this will after approving a request from getting approval from the resource manager, application master will launch the containers. They will talk to each other and get the status, whatever the status of failure or success, and application will finish. Now it is nowhere going to the client because client submitted and client went away. So this is the difference between the client and cluster mode. Now our next part is and last part is why Spark. So why we need the Spark? Although we have different traditional ETL tools, why there is a requirement of Spark. So as you know, like Spark is supports the in-memory computation. So this is a very important factor in considering the Spark as a tool for processing a huge data. So as we have many data nodes running in parallel, and those data nodes are having a RAM which is maybe 40 or 60 GB depending on the configuration. So most of the data computation uh, is is done inside the RAM. So IO disk IO is reduced, so computation is obviously faster. Then next is the scalability, wherein you can add as many as worker nodes as per your requirement. You can scale up also. You can uh, uh, add more worker nodes, or you can reduce also. You can uh, as per your requirement you can reduce. So this is called as a horizontal scaling, wherein we go on adding the worker nodes horizontally. And third is a polyglot, wherein it supports, as we said before, also in the Scala layers topic, that sorry, in the Spark layers topic, it supports Scala, it supports SQL, R, Java, and Python. So whatever is our expertise, it gives the flexibility to the programmer to use these languages. Then it's the last point is the good for high latency apps. So obviously, if you're dealing with the large and huge set of data, latency is the come to picture because your query response time will be little higher. So to process this data in stipulated time, Spark processes that data. It's not like it's not like a OLTP system wherein we are processing the small set of data, and so only subset of data is accessed. Here we are doing history analysis, like we are doing trend analysis for particular company, or maybe analysis of the products over the last decade. So you will be having a huge data. So it's good for processing such huge amount of data where latency is high. So with this, we come to the end of this video. I hope this you will find this video interesting, and thanks for listening. If you want more information about the courses, you can visit zillostech.com. And thanks for your patience. Thanks.